We have all the fasteners wire wheeled, and I showed you me taking this. This is the worst of the three, of course. This is the one that had all the corrosion on it. Taking it to the wheel and cleaning it. You can see there, I think, all the pits and that the corrosion eroded the base metal away. And that's why I'm going to use evaporust, because I'm not confident wire wheeling will get down into all those crevices and cracks and crannies. And I suspect there is still corrosion in there that I can't remove effectively with the wire wheel. So all of these parts will next go into the evaporust bath. The rest of the parts cleaned up pretty well, and they're actually in very good shape. I think, as you can see there, the heads and everything. This one we've talked about before. This is the swing arm pivot. These three bolts, this one, I think it was one of these, this one did have a little tool damage right around the edge here, so I touched it up with a file that flattened it out a little bit. Not bad. And this nut also had some tool damage. I'll come back to that in a minute. Back to the longer of the three bolts, that would be this one right here. I did notice something unusual when I was, or interesting when I was wire wheeling it, and that is these washers on this longest of the three motor mount bolts. This is the one that goes on the very bottom of the engine through the frame, are different size than these two, or these four. These four flat washers are the same. These two are different. So I was thinking, well, maybe someone had replaced these somewhere along the way. So I went and checked the parts diagram, and in fact, the longest bottom motor mount bolt uses a different flat washer than the other two bolts. So again, these four are the same. These two are a different part number from these. However, there's another interesting observation, and by the way, the lock washers are all three the same. The other observation I had is these washers are not identical in size either. Not quite. They're close, but this one in my right hand is just ever so slightly smaller than the other. So again, I don't know if that was done that way at the factory, or they one or both were replaced somewhere along the way, but these two are a different part number than those. And in fact, these, you can see, have some bending and damage to them. What I think I'm going to do is I'm going to go ahead and replace these washers and nuts. I'm going to have to replace these two anyway, because even if I flatten them out, they are two different sizes, so I'm not confident those are originals. I think these are. But I think while I'm replacing the nuts and washers, I'm just going to replace them all. Again, this nut had some damage, tool damage to it. I cleaned it up pretty well, but for a few bucks I can replace all of these nuts and washers with new, and they'll look consistent and be done with it. Now on the swing arm pivot, I'm not going to replace those washers or that nut. I think I'm going to keep those, even though those are of course readily available. It will depend a little bit though. I will go ahead and plate the nut and washers on the swing arm pivot. I am not going to attempt to plate these or these washers and nuts here. I'm just going to plate the bolts, and I will plate the washers here as well. I'm just going to set those aside and not plate those for now, and eventually when I order some more parts, I don't have any order pending right now, but in the future I will order new, and then when I put it together I'll use the new hardware. But little discovery there as I was doing the wire wheeling. What will happen next is these parts will all go into the evaporust bath, as we've talked about, for 24 or so hours, and then I will take them out and we'll take a look at them at that point and pick up the video here in a day or so. It's about 24 hours later, and as you can see, I've just pulled all the parts out of the evaporust bath. You will likely notice I added a few things. This is the Kickstarter arm and the cap or the cover at the top of the steering stem. I thought while I was working on these parts, I'll go ahead and clean these up and prepare them for plating as well. This is the C-clip or the C-clip, E-clip that goes with the kickstart arm, as well as the washer, thrust washer. I think most of the rest of these parts, well, here we've got the bolt that goes with that kickstarter also. Most of the rest of these parts you've already seen. Swing arm, pivot, etc. What I'm going to do now is rinse these parts in clean water. I will do a visual of them. And then depending on the condition at that point, whether I'm satisfied or not, they might go back into the bath again for another 24 hours. Either way, where I'll probably pick this up is after these have been finished being stripped of corrosion and rust, and we'll be going into the muriatic acid bath to strip off the remaining zinc that these parts have on them. So I just wanted to give you a shot of what it looked like at this point. And again, we'll pick this up when we're getting ready to strip the zinc. In a couple of days, I had a few other things to tend to, so I took care of those. Now we're back to this project. These are the parts after they've been wear wheeled twice and dipped in evaporust twice. And then, just for grins and giggles, I threw them, all these parts, in the tumbler. I'll talk about my tumbler probably in more detail at another time, another place. It won't really be part of this video. I have mentioned the tumbler in the past, and I'm thinking about doing a video on shop tools. Excuse me, and tumbler would probably be part of that. But I took a different approach this time by tumbling them, and I did that just to brighten up the finish. I usually don't tumble them before I strip them of zinc and then go ahead with the plating, but I want to brighten up the finish. Now, some folks might say, what's wrong with these parts? They look fine just like they are. Why don't you just go ahead and get on with things? Well, the problem is much of the zinc is actually missing, and what you're seeing in most cases here is polished steel, not polished zinc. In this this kickstart arm is a perfect example. This section right here, which is actually the back of the arm, is still zinc, and you can see how nice and bright and shiny that is. As I start to roll it around, you can see here, and certainly here, that's raw steel. And what will happen if you go ahead and reinstall that on the project, eventually it's going to start to rust. You'll start getting surface rust because the zinc is a sacrificial coating in an attempt to prevent rust. And zinc isn't really intended as decorative, though it oftentimes appears that way. You know, it becomes bright and shiny like this. That's not its main intent in this application, is to prevent corrosion. And up here around where the pedal mounts to it right here, this is all raw steel. This is all steel. This is virtually all raw steel. I don't think there's any zinc left on this piece. So certainly you could go ahead and put it back together and call it good, but you will have surface rust that will be reforming, and it certainly isn't going to work for me. In fact, most of these parts fall into this category with a couple of exceptions. This triple tree or steering stem cap is in actually pretty good shape. It does have some spots of missing zinc, especially around here. It might not show up very well in the video, but there's missing zinc here. There was pits of missing zinc around the perimeter when I first cleaned it, and you can probably see it a little bit better on the back side. Most of the zinc is gone on the back. These two bolts, these are the pinch bolts for the triple tree. They're not bad. There is some on one of them in particular, and I'm pretty sure this won't show up on video. One of them in particular, I think it's this one, has much of the zinc missing around the edge here. This one isn't quite so bad. Might have a little bit here. Most of the rest of these parts, certainly the bolts, the motor mount bolts. This one in particular, this is virtually all just plain steel with the exception of right around the head here. I think there's still some zinc, but all of this is just raw steel. Same thing for the other fasteners here. So even though they look good right now, they won't stay looking good, especially if the project is exposed to any kind of weather or moisture or outdoors. It won't take long and you'll start seeing flash rust appear. Now that I've got the parts cleaned of contamination and corrosion, especially corrosion, I still have to do a final wash to degrease them. What I'm going to do is dip them in a mild acid bath solution. This is the ratio or the bath that I'm going to create. And this acid is just a muriatic or hydrochloric acid. I've talked about the acids before that I use. I don't like using them, but sometimes it's necessary. We'll get into that in a little more detail in a few minutes. But it's basically 15-to-1 clean water. And this can be tap water. It does not have to be distilled. 15-to-1 ratio. Another way to phrase it is about 3 liters, 3,000 milliliters of water to 200 milliliters of acid. I'm going to now go create or mix up this bath. I'm not going to show this on camera. It's pretty academic. And then we'll come back and I'll show you what acid dipping will look like. I'm not going to show you all of these parts. I'll just do one of them, probably this one, which is the worst part of the bunch. Before I go ahead and do them all as we were preparing for the actual plating process. We have the acid bath all mixed. Let's talk about mixing of acid a little bit, or actually just working with acid. It's not my favorite commodity to work with. You've heard me probably mention this before. You need to be careful when you're working with acid. This is muriatic or hydrochloric acid. It's very similar to the acids that's used in batteries. And this kind of acid is dangerous to work with and to use. It will ruin your clothes, it will ruin your skin, it will ruin your life if you get it in your eyes. It will blind you instantly, it will burn you severely if you're not careful. Again, I can't overemphasize safety protocols when working with acids. You can see I've got gloves on, I've got an apron on, I've got safety glasses on, and in fact when I mixed this I had a full face shield on in case there was any splashing. At this stage of my life I'm not taking any chances. You shouldn't either. If you're not comfortable working with acids, don't. That's all I can say. But I have taken all the safety protocols. I've worked with acid at work many years ago, and I was taught the basic protocols for safety, and I've used that ever since. And again, I avoid it if at all possible. In this case, it's not. We're going to go ahead now and begin to strip the remaining zinc plating from these fasteners. This happens to be the worst of the 3 motor mount bolts. You can see I've got it wired up here to a piece of copper wire with a crossbar that I'm going to rest across the top of the tank. And what will happen is I immerse this part, the zinc will immediately be affected by the acid, and the acid will actually just dissolve and strip the zinc right off that fastener. It will not, in this concentration, the acid will not really affect the steel. If you leave it in long enough, it might, but we're not going to leave it in that long. This process literally takes a couple of minutes, tops usually. In this fastener, I don't think it's going to take very long at all because so much of the zinc is already missing, except for around the head itself right there. That still has some zinc on it, but most of the rest of the bolt has already been removed through wear, tear, and erosion over the years. This bolt also may not react quite as aggressively, or the zinc rather, on this bolt quite as aggressively as a fully plated part would because there's less zinc to remove. So what we're going to do now is I'm gradually going to lower this in and watch the reaction. It might take a minute. And you can see over here on the right, I hope you can see already some reaction on the right, and in fact throughout the part you can see it starting to bubble and foam. Again, that's not quite as reactive as a more plated part would be, such as this. This I would expect much more reaction from that bolt. But you can now see it's bubbling and there is reaction. I'm going to let that go for a minute or 2 or so and watch it, and we'll pick this up. It's literally 2 or 3 minutes later, and the reaction has stopped, the chemical reaction. The zinc is all stripped from that bolt. You can see I've got the rest of my chemistry all aligned. I've got some acetone here. That's clean acetone. That's a new can. The acetone actually is in this blue top container. This is clean, and of course that acetone is put in here for the final wash. And then I just have a container of clean water here. So what I'll do is take this out, and then I will rinse it in the water like that, just to get that solution off. Then remove the bolt from the wire. Dry it to get the excess water off. Again, that's now raw steel. There is no zinc left on that anymore. The acid will also, this acid solution also help with any residual rust. I find it too aggressive for rust removal, though I know some people do use muriatic acid for that purpose. I think it erodes the steel too much. Now the dried fastener will go into this solution of clean acetone. I'm just going to leave it there. I'm going to leave it immersed. It will not start to rust or flash rust because oxygen can't get to it. I will cover this up to prevent evaporation of the acetone. Now I'll continue on with the stripping of the remaining zinc of the rest of the fasteners. I'm going to do the bolts, the remaining two motor mount bolts, the swing arm pivot bolt next, and then I'll move on to the pinch bolts and eventually work my way into the kickstart mechanism in that cover for the triple tree, but those will come much later. I don't know whether I'm going to strip them all at this point or not. I'll certainly will do these, and then we will come back and set up for the actual plating process. We're going to now get on with the actual plating, and you can see my basic setup here, and I'll just walk you through it real quickly. I've got a clean plastic container here with 2 pieces of zinc. This is the zinc I will be using. This is available at home improvement stores, big box home improvement stores, hardware stores, that kind of thing. And it's used along the roof line of a home, typically, or a building, is sacrificial and will prevent mold and mildew from developing on the roof of the structure. I bought this many, many years ago, probably 15, 20 years ago. It's a lifetime supply for me. You can buy zinc online. You can buy it at eBay, certainly. You might be able to find slugs of zinc in a hardware store that's used for some plumbing and water systems. I just use this because it's easy to work with and it's flexible, and I can cut it with a scissors. So you can see I've got the 2 pieces of the zinc. And we'll come back to the wiring and the hookup of the wiring here in a minute. The variable power supply, you can use batteries for this. I bought this also many years ago. This variable power supply works great for this application. I would not recommend trying to use a battery charger because you can't really regulate the current flow without trying to rig up some kind of a method to do so, using resistors or something similar. So since I used to do a lot more of this than I do now, I bought the power supply just to make it easy and not consume so many batteries. Let's talk about the power, though, or the current that we're going to be using. We need to talk about current for the plating, and we are going to be talking about current or amps, not voltage. Voltage is really irrelevant for our purposes. You need to think of amps as volume of current, not speed of current. Speed of current would be voltage. We're talking about volume here. And usually or often we talk about milliamps, and a milliamp is 1/1000th of an amp. You might get over an amp in some cases, but most of the time, for the work that I do anyway, I deal in milliamps. And the standard reference you'll find online, I've had this for years around, is approximately 140 milliamps of current per square inch of surface area of part to be plated. And that is quoted in square inches. If you're working in a metric system, you could easily convert that to square centimeters, for instance, but I'm just sticking with this because that's what I had in my notes from years ago. So if you think of one of those bolts that I'm going to be plating, one of those motor mount bolts with the Suzuki S on the head, I took the one that was in the roughest condition, had all the pitting on the shaft or the shank, and that measured approximately 4.17 inches long. The radius of the diameter, which is very important because that's part of the formula, the radius is 0.315. You plug those two numbers into a calculator. You can do it by hand. There's all kinds of formulas for this. And it indicates that the surface area of that bolt is approximately 4.3 square inches. Now that doesn't take into account the flared head where the hex is, so the actual square inches of the bolt is a little bit higher than this. Not a big deal for what I'm trying to do here. 4.3 square inches times 140 milliamps means that my starting current should be around 602 milliamps to plate that bolt. And I can set that on that variable speed power supply. You'll see the readout when I turn it on and get going with this. And I can adjust that up or down based on watching the bath and seeing what's happening. Now again, this is part of a formula that's used to determine the square inch area of the bolt. Again, not volume, surface area. Very easily done. This, by the way, is just not a matter of timesing or multiplying these figures together. You've got to actually use pi. It's not that complicated. If you remember high school geometry, you might recall how to calculate area of a cylinder. If not, go online and find all kinds of these calculators available to calculate this for you. Let's talk about a little bit here the wiring hookup on the, let me show you this. I just put a little label on the top of my power supply so I don't forget. It's an easy reference. The red coming out of the power supply goes to the anode, which is these zinc strips. Again, those are sacrificial. And then the black will go to the part. And that's what I've rigged up here. You can see the red wire right here. Let me focus this for you here. You can see the red wire is going to this zinc strip, and then I just have a jumper that comes around and connects over here so that both anodes are connected to the red or positive side of this setup. And then I have a little crossbar here with, again, that piece of copper wire with a loop, and what I will do is I will thread that bolt into that loop. I will immerse it, and of course there's no solution in here, bath right now. That's already mixed up and ready to go. I will immerse the bolt like that into the solution with the negative wire connected here. Again, there's many different ways you could do this, and you have to get creative sometimes in rigging up different shape configuration of parts. You can plate more than one part at a time. You can do as many as you want to rig up, and you have the capability of supplying the correct amount of current or amperage to. I'm going to demonstrate, I'm going to use just one bolt, and we'll take the one bolt through the entire process. So that's really my setup. Again, it's not real complicated, but you just need to think it through a little bit. What I'm going to do now is I will fill this container with the plating bath, the plating solution already mixed up, and we'll get the bolt threaded into that loop right there, and we'll suspend it in the solution, and then we'll start the plating process.